and I hold it above, and I say, would you dare to catch this? Dare to? Yeah. You dare to catch it? Okay. Now we're going to do the same thing. I'm going to go out in an airplane. I'm going to drop it, and you catch it. Would you dare to catch it? No way. Because you know as this thing is falling, it's going to pick up speed. Isn't that right? And to say it picks up speed is to say it's going to be undergoing a process, begin with an A, called acceleration. Okay? And that pickup in speed, that's what acceleration is. And we just saw here, this thing does accelerate. Let me tell you how much it accelerates. It turns out that a freely falling object at the surface of the Earth will have a constant acceleration. And that acceleration will be 10 meters per second every 1 second. Freely falling objects will pick up a speed of 10 meters per second every second they're falling. And I can call that like this. 10 meters per second square. When the acceleration is due to gravity, it's common to let the A be a g. We could say g for the planet Earth is 10 meters per second, or 10 meters per second square. What's that mean? That means this. Let's suppose I drop this. Okay. And there's a speedometer on there. And you guys are looking at the speedometer with a spyglass. Right now, what does the speedometer say? 0. Now, when I let it go, does the speedometer reading pick up? It picks up. At the end of 1 second, the speedometer reading gets up to how much? 10. That's right, because it's been falling for a whole second. So now it's going 10 meters per second, okay? 1 more second, it's going even faster. How much 1 more second? 10. Now it's up to 20. And up to the 3rd second, it picks up another value of how much per second? 10. So how fast is it going at the end of 3 seconds? How about 4 seconds? Can you do big numbers? How about 10 seconds? How fast is it going? Check your neighbor. Okay, not the 10. Okay, let's just say 7. 70 meters per second. Can you do 9s? How about 9s and 7s, man? I can never do 9s and 7s, okay? But 10's okay. 10 is easy, right? 100 meters per second. So that brings us up to another formula. If that's what acceleration is, we can tell how fast things go by just saying this. The velocity that something the velocity acquired when falling is simply equal to the acceleration times the time. And if the acceleration for free fall is always 10, then the speed something picks up is simply going to be 10 multiplied by that time t. That's what we just did. I asked you people, I says, if you go for 10 seconds, fall for 10 seconds, how fast is it going? Where the t is, you put 10. And that cancels out one of these seconds over here. And so what you're left with is 10 tens is 100 meters per second. So a freely falling object will pick up to a speed of 100 meters per second if it's got 10 seconds to fall. How about if it's got 5 seconds to fall? How fast will it be going? What would the speedometer reading be? Check your neighbor. How many say 50 meters per second? Yeah, because every second goes by, it's going to pick up 10 meters per second. It didn't have the second before. And that acceleration is constant. And you know what we're doing, gang? We're forgetting about air drag. We're not going to count air drag. If I take this book and this piece of paper and drop them, the book accelerates much more than the paper. Why? Because the paper, there's a lot of air resistance compared to the weight of the paper. If I take that paper and make it smaller, so now the air resistance acting on it's not going to be so much, they'll fall together. Okay? And we're only taking the case, these are the relationships here. These are for the case where air resistance doesn't count. And we're going to kind of do things that way in this course. We're going to take the easiest way all the time. You know why? Because the easiest way is a lot. We're not going to complicate things by talking about the air drag, at least not at this point, or even the buoyancy, the amount of air that's displaced and all that. We're going to learn the simplest physics we can, and we're going to learn it well. And then when we learn that well, then maybe some other time you can put air drag and buoyancy and all those other things in and make it more complicated. We'll always take the easiest way and learn a lot. Better to uncover a little than to cover a lot. Now I got a question for you, gang. Let's make believe this is a little test. Let's suppose we get up here again. I take the object and I drop it. Make believe this is a quiz. And I drop it. 1 second later, I say stop. 1 second later, that thing has got speed it didn't have up here. Check your neighbor and see if your neighbor knows how much speed does it have after 1 second. Go ahead. It's a review. How many said 10? Show of hands. Look at the hands that aren't up. Okay. Let me tell you how we got the 10, gang, okay? When you drop something, it's going to keep going faster and faster. How much is it going to go faster every second? 10 meters per second, right? Every second. And we said 1 second, so the answer is, begin with a T, 10. That's how fast it's going, right? Let's suppose I had dropped it for a longer time and it took 2 seconds. I say 2 seconds later, what's its speed? And you would say? And if I said 7 seconds even, you would say? Okay. Now I'm going to ask another question. I take it, I drop it. 1 second. 1 second later, how fast is it going?
10.
How far is it falling?
10 meters.
Ah. I switched. I asked how far. I didn't ask how fast. How fast is 10? How far is not review? How far brings up a new idea? How about it, gang? How far? How many say 10? How many say 5? How many say I don't know? How many say, I know, don't know, I don't need to know, I don't care? No, come on. Let's look at it, gang. Let's look at it. If you say 10, did it have an average speed of 10? See, it fell for 1 second, but its average speed wasn't 10. If you take a couple of quizzes, and the first quiz you take is 0, and the next quiz you take is 10, and someone says, how you doing in physics? Oh, I'm doing, I got an average of 10. No.